Hello, everyone. Thank you, and welcome back for more of Hope 2020. A big thank you to all the attendees, presenters, and volunteers who have made this virtual version of our conference so successful. So right now, we're going to take it into our next speaker, which is the 703 Locksport Crew. Their talk is Introduction to Locksmithing. Please remember that during the presentation, the speakers will be live in the Hope 2020 Matrix Chat Q&A. Please submit your questions to the Matrix Chat window, and we'll do our best to present your questions to the speakers, time permitting. Take it away, 703 Locksport Crew.
We are the 703 Locksport Crew. This presentation is going to go into some basic locksmithing tasks. Ultimately, we're going to build to a rekeying demo, but we've got to set the stage with a bunch of prerequisite information first. As far as simply defining rekeying, rekeying is the process of changing the key that operates a lock without buying an entirely new lock. There are a number of reasons you might do this. When moving into a new house, you might want to rekey the lock such that the prior owner's key no longer works. If you do have a lock that breaks and you go out and you purchase a replacement, you're probably not going to want to have to replicate that key to everyone that has a key that gets into your house currently. It would be more sensible to alter the key that works the lock. That'd be another use case for rekeying. Rekey can also be used to consolidate multiple locks onto a single key. Consider your house. You might have a front door, a back door, a basement door, a garage door. Maybe there's a knob, and a bolt. You could have 6 to 8 cylinders to deal with there. You don't want to carry around 6 to 8 keys, so rekeying is how you would consolidate down to a single key.
Now let's go into the pin tumbler lock and the key anatomy. So this is what a pin tumbler lock would look like if you were to explode it. Most of these parts will be familiar to anyone who spent any time in a Locksport village at a convention. In this talk, we're going to disassemble a lock that's basically the same as this one. We're going to be using this core type, but most pin tumbler locks will work exactly this way, and most locks that you run into are going to be pin tumbler locks. You can see on the front we've got the plug that actually rotates. We've got bottom pins, which are normally called key pins. We've got top pins, which are normally called driver pins, and then we've got springs. The reason we don't normally call them top pins and bottom pins, it's a bad habit, because many locks are oriented in different directions, upwards, downwards. In the UK, they have them upside down on all of the locks. And at the back of the lock, you'll see there's a tailpiece. That's what actually interacts with the locking mechanism, so like the bolt on a deadbolt. And then we've got a little spring and a retaining pin that holds on a retaining cap. And you can see the retaining cap has some threads, and it screws onto the plug, so that holds everything together.
The parts of a key for a pin tumbler lock. The key's basically divided into two parts, the bow and the blade. The bow is comprised of the head, the collar, and the shoulder, and the blade is comprised of the bitting cuts, profile contours, and the tip. The key plus key pins equals a shear line. And inside a lock, the key pins are of different sizes, and when you put the correct key in the lock, that pushes all the key pins up so that they are level at the top, and this is what's called the shear line.
Let's jump straight to figure 3 here. Note that just like in the last slide, the pins and the bitting cuts complement each other such that an even shear line is created. In figure 4, we have opened the lock. Note that when it is opened, your key pins remain in the plug and the driver pins remain in the Bible during the operation of the lock. If we were to jump back to figure 2, we will see that the wrong key has been inserted and the plug is obstructed from turning by either a key or a driver pin being out of place. Figure 1 just illustrates a lock at rest with no key in. All right, we can do a little bit of audience participation here. If you want to get a hold of your keys, take those out and take a look and see if you have either of these two keys on your key ring. Given that they are the two most common residential keys, it's pretty likely you have one or both on hand. The first step to identifying a key is looking at the bow. Most lock vendors have a distinctive bow shape to identify their brand. The second step to identifying a key is to look straight down the tip of the key to get a view of the profile milling. This is another distinctive pattern that varies for different vendors. The profile milling has to match up with the keyway for the key even to be able to fit into the lock. The Kwikset key is not going to fit into the Schlage keyway, and the Schlage key is not going to fit into the Kwikset keyway. And the bow and profile variations just keep going. There's as many of those out there as there are vendors. See if you have any of these on your keyring. Some of these are more residential-oriented vendors. Some are a little bit more commercially oriented. Another thing to notice is that some of these key examples have the same bow but different profiles. So you really do need to look at both of those in order to identify the key. If you look at the lower left corner, you will see a Schlage key blank listed as Schlage C. This is the keyway used in the demonstration throughout.
Now this is the most common Schlage blank in use. It is commonly called the SC1. These can be obtained from Schlage, or there are a ton of other companies that make these, basically like knockoffs or generics. Now take a look at your keys. You'll probably see that some of these keys would have the Schlage bow or the Kwikset bow, but they do not have Schlage or Kwikset stamped in those. Those are likely going to be keys made by a third-party vendor. Third-party vendors also make most, if not all, of those keys that have like the zebra patterns or pink bears or whatever. And then there's one more thing to consider when you're identifying the key is the length of the key. Not all keys use the same number of pins. More pins requires a longer key. The SC1 is a 5-pin blank for a 5-pin lock, but the SC4 is the same exact key as the SC1. It's the same keyway, it's the same profile cuts on the side, but it's slightly longer so that it'll have space for a 6th pin. So you would use the SC4 for a 6-pin lock, you'd use the SC1 for a 5-pin lock. Now, different vendors have different part numbers to describe things that may be pretty much the same or compatible with each other. Schlage describes this keyway as the C keyway, but Ilko describes the blank that fits the Schlage C keyway for a 5-pin lock as an SC1. That's sort of an industry standard. Just about everyone calls it an SC1. Hillman has a blank that fits the Schlage C keyway for a 5-pin lock, but they call it the Model 68. A really helpful resource for identifying keys is a key blank directory.
If you ever get too deep into things, like we have, you may want to get yourself a key blank directory. This covers a lot of information. This is going to cover residential keys, cabinet keys, automotive keys. One note of interest here is while mastering is beyond the scope of this talk, this does get into mastering systems based around different key blanks, some of which will fit into common keyways and some which won't. And this gets all the way into exotic key blanks like skeleton keys. Anything you want to know about key blanks is going to be in a book like this.
Now let's take a look at decoding a key. Most people would think of inches or millimeters for units of measurements when tools are involved. When you're buying drill bits, sockets, hex keys, or even crescent wrenches, units of either millimeters or some fraction of an inch is what they use to describe the size. However, locksmithing is basically metalworking. So we usually use the standards or the conventions that have been established by machinists. Now, we don't get metric, but we do get our own pseudo-metric, I suppose. It's called thousandths of an inch, or thou. Now, if you've ever purchased a plastic drop cloth for painting labeled as 3 mil or 5 mil, or even sometimes they'll sell gloves in this thickness, a mil is just a different word for a thou, or a thousandth of an inch. Thousandths of an inch are not difficult to translate into more relatable terms, because 1 inch equals 1,000 thou. A half inch would be 500 thou, a quarter inch would be 250 thou, and an eighth inch is 125 thou.
Here's where we get deeper into bitting cuts. Everything related to a key follows extensive specifications, from where cuts are centered on the key to the depth of each cut. A root depth is a measure from the deepest portion of a cut to the underside of the blade. Essentially, the root depth is the amount of material remaining after a cut has been made. The root depth is measured in thousandths of an inch. As you can see on the right, there is 10 root depths specified, one corresponding to each pin available for use with this vendor. A small root depth measurement indicates a deep cut to accommodate a longer pin. A larger root depth measurement indicates a shallow cut to accommodate a shorter pin. Measuring the root depths is how a pin number for a given pin position is determined. Once all the root depths have been measured sequentially from bow to tip and converted to pin numbers, you now have what is known as the key code. On the left are all the pin lengths specified for the various pin numbers. Pins get longer as the number increases. Again, the pins are measured in thousandths of an inch. Obviously, no one has a ruler or a tape measure graduated in thousandths of an inch. That'd be really hard to see. To measure root depths or the pins themselves, you're going to need a set of calipers. You can get calipers as either analog with a dial, such as this picture, or digital. The key is pinched perpendicularly within the jaws of the caliper, taking care not to skew it off at some screwy angle. At the top center of this picture, you will see a 1 and 2 mark. The 1 is for 100 thousandths, the 2 mark is for 200 thousandths, and then you go to the dial and you find 31. The root depth measurement at this pin position is 231 thousandths. All right, there's a lot going on here. Let's start at the leftmost column. Here we have all the pin numbers. The next column over lists out all the root depths for these pin numbers. Using the 231 thousandths measurements from the prior slide, we can see this corresponds most closely to the root depth for a pin number 7. Granted, we're off by a thousandth of an inch. Was the key cut correctly? Were the calipers zeroed? Who cares? It's within the tolerance, and chasing down this type of ambiguity is pointless because this is the type of ambiguity you need for lockpicking to even be possible. Going one more column to the right, we have the pin lengths. Notice if you were to add the root depth to the pin length, all the numbers total up to the same value, 500 thousandths. That means the shear line is 500 thousandths, or 1/2 an inch, above the underside of the key blade. It is also worth noting that the delta between each pin size and root depth is always 15 thousandths of an inch for this vendor. You should see an internal consistency beginning to develop for this. This behavior is consistent across all locks, but the measurements for the root depths and the pin lengths varies between manufacturers. Schlage and Kwikset locks do not have the same number of pin size choices. Schlage has 10 pins, whereas Kwikset has 7. Additionally, Kwikset uses an increment of 23 thousandths versus Schlage's 15 thousandths.
So another option that we have for decoding keys is a vendor-specific key gauge. These are basically pieces of sheet metal that have been stamped with a sort of staircase pattern. Each step of the staircase corresponds to a root depth on the key, and the key code numbers will be printed above or below the corresponding step. These are vendor-specific, though they are sold by third parties as well as the original manufacturer. There are some third-party key gauges that support multiple vendors. The Lab Company, for example, sells one that has Schlage, Kwikset, Master Padlock, and a couple others on the same one. One downside of using a key gauge is that worn out or poorly duplicated keys will be nearly impossible to read sometimes. And since key gauges are only useful for certain vendors, as soon as you find something weird, you're probably going to be reaching for your calipers anyway.
Just to review, key codes are recorded by their pin number. The key code is written left to right, and it corresponds to the positions running from the bow to the tip. I'm going to go ahead and decode this. I'm going to first do this with the key gauge, and then I'm going to sanity check 2 measurements with the calipers. We're going to be working from the bow towards the tip. This is a 6, 5, 1, 4, 9. I'm going to go ahead and record that as 65149. And then we'll sanity check with the calipers. We're going to first do the position closest to the bow. Got a measurement of 245. If we look at our root depths here, we can see that measurement aligns with a pin 6. Go ahead and do the tip end. We know this is a 9, and I've got a measurement of 200 thousandths. If we refer back to our measurements here, 200 thousandths equates to a 9. So we can confirm that the key gauge and the calipers are both usable ways to decode this. One final option we can look at is since we have an original key, this actually does come with the original code stamped on it. If you happen to have your key ring on you, pull your key ring out, take a look at the keys, see if you can find any key codes already present.
Now on to parts of a repinning kit. This is the world's cheapest pinning mat. It does keep the pins from rolling away, it makes pins easier to see, brass on white, and it keeps graphite or grease from getting everywhere. Pinning kits include key pins, driver pins, springs, key gauge, cylinder cap removal tool, plug follower, spare cylinder caps, and spare tailpieces. Improvised pinning kits is a small parts tray, 9 key pins, 3 driver pins, springs, and various tools. Here you see 2 different types of plug followers, a key depth gauge, an example of good pin tweezers, which are very small and will allow you to get into the housing, awful pin tweezers, which are too large for you to really do anything useful with, and a cylinder cap removal tool and a fine point Sharpie to write down your key bitting. To build your own kit, it's approximately $28 on Amazon. You get 50 driver and key pins, you get a plug follower, key gauge, and the wrong cylinder tool for Schlage. Springs, about $5 on coksupplies.com. Cylinder cap removal tools, about $13 on Amazon. Pinning tweezers, about $12 on clksupplies.com. Also notice the cupped profile at the tip for actually grabbing the pins. Official vendor kit's about $120 on Amazon and does not include pinning tweezers. Universal repinning kit is about $50 on lockpicks.com, includes pins for Kwikset, Weiser, and Schlage. No cylinder cap removal tools, no plug followers, no key gauges, and no tweezers. Calipers, $10 to $40 on Amazon. Also don't discount analog calipers, the batteries can't run out on those.
Now we're going to take a look at cylinder disassembly and the infamous plug follower. So if you've seen a lock cylinder, typically the place you've seen this is in lockpicking villages. In lockpicking villages, the tailpiece is usually removed and there's obviously no latch attached to the tailpiece. So they'll kind of just spin forever, 360 degrees. For a lock that's actually going to be installed somewhere, the tailpieces will intersect the latch here, and that's what's actually going to throw the bolt in and out, or your latch, as the case may be. And obviously you can't spin this one 360 degrees when it's installed. It kind of just gets the set left and right, usually around 180 degrees. Now let's take this apart real quick. As you can see, I'm very fast. Now, just a note, the bulk of what we're going to be dealing with is this Schlage key and knob type cylinder with the screw cap. But I would like to illustrate here that the Kwikset style has this sort of circlip on here. So there's nothing to unscrew when you're trying to take it apart. You just kind of pry it off with a screwdriver or tweezers or something. Now, in my experience, the circlip is the least common denominator of this lock. It's the most common failure point. They'll get tired after a while and just split apart, which drops the tailpiece out, separates the plug from the locking mechanism. Both sides are pretty similar to each other, as you can see. Here's the other one. It's about the same. And of course, this is the front of the cylinder.
Here we have 2 different locks featuring 2 different examples of tailpieces. The lock on the left is a mortise lock with a cam attached. The plug is retained into the housing by a tailpiece held on with 2 screws. On the right side, we have a cylinder, much like what we're going to be demonstrating with. The tailpiece is held on with a cylinder cap, and that cylinder cap is held in place by a little retention pin. One other note about the lock on the right, the cylinder is held onto the body of the lock with a set screw. This is referred to a key and knob type cylinder. It's a pretty standardized type of form factor that is modularized for lock cylinders. The entire lock cylinder can be pulled out and replaced with a different keyway if you want. As you can see, the same form factor cylinder is available from multiple vendor keyways. Schlage, Sargent, Yale, Kwikset, Russell, and whatever it is you want. Conceivably, if you had a really nice ornate door with a forged brass handle or something like that, and it was set up for Yale, and you had Schlage locks on the rest of the house, in order to rekey those, that would include the process of actually changing the keyway. This is the type of part you would look at to replace the keyway. These are the cylinders that we're going to be demonstrating a rekey with. They are GMS Schlage C keyway key and knob type cylinders. The cylinder cap and the plug are threaded together, just like a machine screw and a nut. You can't unscrew that cylinder cap though, because it is held in place by a pin. There's a little pin that fits into that sort of scallop that's around the interior of the cylinder cap and locks it in place. That pin is spring-loaded, so you have to depress that before you can unscrew it. There's a number of ways you can do that. You can depress that with just about anything. A paper clip, a lockpick, a center punch, whatever you've got. Alternately, if you want to spend the money for it, you can get a cylinder cap removal tool. That tool there has some little ridges around the end of it that are going to fit into those scallops, and it's going to allow you to depress the pin and unscrew the cap simultaneously. The tool itself is hollow, so the tailpiece will fit up inside it while you're working. Once you've disassembled it, that is the tailpiece off, that is the cylinder cap, and you can see the little retention pin and spring. You're not going to want to lose any of these items. Using a plug follower is a lot like the dilemma Indiana Jones finds himself in here. You're going to have to very rapidly remove one item and replace it with the other, or chaos ensues. So once you've taken the cylinder cap off the plug is essentially being held in place by just the pins and the springs that are in there. If you put your key in there and you get your key pins up to that shear line, nothing's holding it together anymore. At that point, the whole thing can fall apart. And that's not what we want to have happen. What we're going to do is we're going to take a plug follower. Plug follower is a cylinder the same diameter of the plug. You have to put it in direct contact with the plug at the tip end from where you remove the cylinder cap from. And then you're going to withdraw the plug and simultaneously push the follower in behind it, leaving no space. Optimally, the goal here is to keep the driver pins and the springs retained in the Bible. Your plug comes out, your key pins are going to be in the plug. This is a posed photo. It doesn't look quite like this when you go through the process yourself, but as you can see with that cutaway cylinder there, you can see that that plug is in direct contact with the plug follower, and you want to keep all those driver pins and keys retained up in that Bible. Best case scenario, this is what it looks like when you're done. And here we have the plug removed and the plug follower in its place. All the driver pins and springs remain in the Bible. The key pins are all in the plug, showing you a nice even shear line. One thing you may notice immediately is that there's an empty position at the end of that plug. This key and knob cylinder is interesting in that it is made to be utilized with either a 5-pin SC1 or a 6-pin SC4 type key. It's just a matter of whether or not you actually install driver pins and springs and key pins in that last position. So the one thing you've got to take into consideration when taking this one apart is if you put the key in and you just withdrew the plug straight back, the driver pin in position 5 would drop down into the hole in plug position 6 on the way out. So what you have to do is put that key in, offset it, say 45 degrees, so that the only thing up against the key pins is going to be either the even metal plug surface or the plug follower. Nothing for it to fall into. I'm going to go ahead and demonstrate the best case scenario for using a plug follower. This is how it should go. Put your key in, turn it, get your plug follower, push this through, nice and smooth, all good. You will feel like you need 4 hands the first time you try this.
You will screw this up and explode your lock on the first try. So let's just concede that event, and we'll show you how to recover from such a state. So this is the worst case scenario. Chaos reigns, all is lost, the dead walk the earth and feast upon the living. So you want to organize everything. Use your tweezers. Organize your springs together, your key pins, and your driver pins. Your key pins are going to be varying sizes. Your driver pins will be all the same size, and they're flat on both ends. Your key pin is flat on one end and sort of pointy on the other. Now you want to put the plug back together. So you're going to put the key back in the plug. You have the key code. The largest pin number is the longest pin. Put whatever looks correct in that position. Do the same thing with the smallest pin number. Work through all the pins. The pin should create an even surface across the plug. Then you want to put the bottom pins back in the plug. Now you want to reinstall the driver pins. This is the tedious part. Insert the plug follower, slot it in first via the tip or the tail end of the cylinder. Advance forward such that the slot is over top of the bow end shaft of the Bible. Insert a spring. Insert a driver pin. Use the plug follower to center the driver pin. Push the driver pin down into the Bible, compressing the spring. Advance the plug follower forward.
Alright, so this is probably closer to how things are going to actually go when you first use a plug follower. Every time we try to teach somebody this, they'll pretty much always mess up the first time. It's inevitable with this. So we might as well intentionally screw it up and show you how to recover from this. This will also tell you how easy it is for the lock to just fall apart when you aren't so careful. So right now this is fine. It's not going to fall apart even though the cylinder cap is removed. The lock is held together by the pins and the springs inside. But if you were to put a key in, like so, at this point you are in the danger zone. The whole thing can kind of just come apart on you. It's not going to come apart because I'm trying to demo it, but come on. There we go. Okay, so here's our worst case scenario. We've got our parts all over the place. We've disappointed our family. We failed the calculus test. Income taxes are due. It's basically just a summary of the year 2020, to be honest. We can start to put some order to this chaos by just sorting things out. So we'll see if we can move the springs to one pile. Over here. That one. Should be 5 of each because it was a 5-pin lock. So we got 5 springs. Now we'll move the driver pins over here. The driver pins are all the same size. They don't have that little bevel on them. And then that's 5 of those. So we'll move the key pins over and we'll arrange them by biggest to smallest, I guess. Now it's a little bit hard to see this. I mean, it's hard to see on camera, but it's also hard to see in real life. But we'll just kind of approximate. We don't have to make it perfect. So now we can basically guess by order of elimination which ones go where, because we do have the key and we have the key code, which I wrote down here. So let's take a look at this. We'll put the key in just so we can check our work. And then we know that the 9 is going to be the longest, and this pin here looks to be the longest, so I'm going to put that in position 5. And the shortest is a 1, so I'll put that in chamber 3. Now, I guess these 3 are pretty much the same size, but this one looks to be the shortest, so I'm going to assume that's 4 and drop it into chamber 4. The next smallest is 5, so I'm going to drop that into chamber 2, and then we've only got 1 pin left, so that belongs in chamber 1. And you can see they all line up on the key. I think we're in good shape here. See that? And naturally the 6th pin is missing because this is only 5 pins. Alright, this is an awful and tedious part of locksmithing. This is reinstalling a spring and driver pin in the top. I'm just going to install one of them for now. This is what the groove portion of the plug follower is actually for. You'd want to line it up with the chamber. We're going to line it up with that first location. Drop in a spring, usually just drops in. We got to take the driver pin, put it in there. Then you want to rotate it till it's basically lined right up, and then you can just push it down. There we go. Get it in the hole, little pressure, and advance the plug follower. Let's put the first pin in the plug. We're going to drop that in chamber 1. And then we can insert the plug. You got to pinch this with your thumb to remove the key, otherwise it's just going to fall down. Now let's put the spring in there. That's the really small spring. And then the pin. Throw on the tailpiece. And then we'll put on the cylinder cap and grab that cylinder cap removal tool, spin it on. And there we go. Now we have a 1-pin lock, just like what you'd find at a lockpick village. You could do this with 2 pins, 3 pins, 4 pins, or you could actually fill in all of 5 or 6 pins.
Changing key pins. Decode a new key. Use a key gauge or calipers to decode a new key. Write down the key code left to right, bow to tip. Remove the plug with existing working key and dump the key pins. Put the new key into the plug. Insert appropriate pins in appropriate positions. Pins should form an even, smooth surface. Then you want to reinstall the repinned plug. Replace the plug follower with the plug. Remove the key. Reinstall the cylinder retention pin and spring. Reinstall the tailpiece. Reinstall the cylinder cap. Test the key. If it feels tight when turning, back off the cylinder cap a little. If it doesn't turn at all, you screwed up and need to pick it open.
Alright, what we're going to do here is rekey this lock. So right now, the key code for this lock is 65149. And we're going to be using this other key, and that number is 72756. The first thing we've got to do is disassemble the lock. I'll take the tailpiece out, use the cylinder cap removal tool, put the key in, and then put in the plug follower. We don't have to worry about the top pins, they're going to stay the same. So you just dump the key pins, put the new key in. We're going to grab a 7 from the pinning kit. Grab a 2. There we go. We'll want a 7. And this is where pinning tweezers come in really handy. Grab a 5. And there we go. So you've got all those pins in there. And that's it. Now we'll put the spring in and the back pin and put in the tailpiece and the retaining cap. And we'll screw it back on with the cylinder cap tool. And we now have a repinned lock. It is working with this new key, which is the 72756. And the original one, 65149, no longer works on this lock. And that's all there is to it.
We managed to come up 5 minutes short on content, so we're going to attempt to speed teach key origination. We're going to revisit this diagram from the beginning of the presentation. The first time we looked at this, we were concerned with the root depth measurements. This time around, we're concerned with the spacing. As you can see, at all of these positions, there is a measurement indicating where the cut is centered in reference to the shoulder of the key. Position 1 is centered at 231 thousandths off the shoulder of the key. Each subsequent cut, I believe, is 156 thousandths further along than the prior one. Key origination, also known as cutting by code, is the process of creating a key essentially directly from the key code. Most people are probably familiar with copying a key, in which case there is an original and the bitting cuts are traced off of that key onto a blank, thus duplicating it. In this case, there is no original key. What you need is a machine capable of making controlled cuts at specific spaces, at specific depths, to replicate a key code. Just as with the root depth, how they vary per vendor, the spacing is another characteristic that is going to vary per vendor. This is a Framin 2 key origination machine. This is a lot like a milling machine in that you've got kind of XY controls on it. One of those would be a spacing control, which you see on the right. The depth control is in the bottom center. Both of these dials are graduated in thousandths of an inch. There's a vise that holds your key bank in place, and then between these two dials, you're going to control what depth is cut at what location. All right, what we're going to do here is we have a key that opens this, and we are simply going to use the key code off of this original key as a guideline for what we're going to cut on the Framin 2. And our key code is 65756. And we have written down the root depths associated with that key code. And that is going to be the basis for guiding us through these cuts. The first step to using this machine is zeroing up this spacing block. So this thing gets run until the vise is all the way over to the left. And there we have our 0. What we're going to do now is each rotation is 50 thousandths, and we're going to spin this up until we get to 231 thousandths, which again is the measurement for centering the first cut off the shoulder. Here's our 231. This spacing block is now moved so that the first tick mark there lines up to the tick mark on the spacing guide. That hexagonal block there has graduations, tick marks, every 156 thousandths. It might be hard to see, but that hexagonal block has different faces on it. Each face of that is set up for a different vendor spacing. We have our key in the vise. We did a little check there on the shoulder to make sure it was lined up. And now we are proceeding to dialing up the first root depth. Turn on our machine. This blue handle here will drive the key into the cutting wheel. And this operation here is essentially depth stopped based on whatever we dialed up on the depth dial. Here we advance the spacing. Once you've set the first one to 231 thousandths, you don't have to continue to measure. All you do is you crank this thing to the next tick mark on that hexagonal block. You definitely always want to remember to actually go through the process of advancing the spacing after making a cut. If you forget to advance the spacing, you can potentially cut the same position twice, thus ruining your key.
Yeah, I've never done that.
It's too bad we didn't record audio so you could hear all the hideous screeching noises that this makes. I believe we're coming up on our last cut here. We have cut from the bow to the tip. One operation not shown is once this key has been cut, it has to be buffed off. There are metal burrs on the edges where those cuts are. And now we have a new key cut to code that works that lock. All the material that was presented here today was adapted from a live workshop that we ran a grand total of once prior to the shutdown. Hopefully in the future we can run this live again. There's obviously more key machines here than just the Fremen. There's a lot more to learn, and there's much greater value in doing this hands-on versus just doing it as a demonstration.
All right, that concludes our introduction to locksmithing presentation. This has been the 703 Locksport Crew. We got a couple of quick shout outs over here, as per usual. And we'll now be opening for question and answers. So if anybody's got any questions, just shove them down in the comment section or chat box or whatever they got here.
Hi, and we're back with Hope 2020. I want to give a big thank you to the 703 Locksport Crew. Your presentation was excellent. Really nice job, guys. We have with us Haipu and Michael. Say hi, guys.
Hello.
What's up?
Hey, well, I'm glad that you're able to be with us. We have some great questions from the Matrix Q&A, and I'll get right into it. Our first question is, what is the best cylinder cap removal alternative if you don't have one?
If you don't have a cylinder cap removal tool, you can improvise with a number of things. All you really have to do is be able to depress that retention pin down a little bit so you can manually unscrew the cylinder cap. You can do that with a paper clip, a center punch, or a lockpick. Just about anything will work.
Thank you. All right, our next question. Have you ever come across an electronic lock that isn't hilariously insecure?
Yeah, so electronic locks, this is Haipu. Electronic locks are pretty notorious for their fundamental flaw of you have to interact the electronic mechanism with a physical mechanism, which requires basically a solenoid or a motor or something that relies on magnets. The cool thing about magnets is they're not restricted by the government or anything. You can buy them. So and nobody seems to bother shielding their locks properly. So I haven't personally come across any electronic lock that isn't hilariously insecure. That doesn't mean it's impossible, but I just haven't seen it. So,
got it. Thank you. Our next question is, we'll give that to Michael. Any downside to buying a key originator used?
Yes, you can conceivably get a machine that's out of spec, which actually did happen to us. We bought an HPC Blitz off of eBay, and when we went to use it, we originated keys that just would not work. We were able to salvage that situation, though. Since we have a known good machine, we were able to cut a depth and spacing key set, which we then transferred over to the HPC Blitz. And I will turn over to my colleague to describe how that process went.
Yeah. So that process was not exactly graceful. We cut a depth and spacing key set, which is basically 10 keys. We were calibrating using Schlage because it's handy. So we had 10 keys, bidding 0 through 9, and basically all 6 positions were cut to that respective key code. We cut that on another machine that we had a known good calibration on, or good enough, and then we basically measured where the cutting wheel would be if it was pushed up against that key, and we made a mark and we made our own card. So we didn't actually calibrate the machine because the calibration kit that we purchased, basically we went through the little flow chart or whatever, and the calibration recommendation for our specific situation was send it back to the manufacturer and pay a couple grand or something. So that's not what we do here. So we just made it with a pencil and a piece of paper, and it's good enough. So you can run into things like that. Maybe you could have a saving grace like us. Maybe you won't. And maybe it's worn out. Maybe there's a reason you found it on eBay for a couple $100 when it's $1,000 machine. So just kind of be careful and know that you might make a mistake, and that's probably okay.
Got it. All right, thank you. When you get a key copied and it ends up not working, what specifically went wrong usually?
I think Michael's the expert on that.
I don't know if I'd be the expert, but I'll go ahead and try it. I mean, there could be a number of problems. One of the common issues is the key you're starting with, your original, could be a copy that's generations away from the original. It could be worn out. There could also be calibration issues with the machine. So you could either be copying a bad source, or you could have issues in the process of copying. It's hard to say.
All right, our next question is, do you have a similar cutting guide to dimple locks?
I do
So-
not. That is a radically different set of keys, and I will let my colleague describe that to you.
Yeah. So dimple keys look really complicated and fancy. That's basically just the novelty. They're not actually fancy. It's just a pin tumbler lock turned on its side. The pins are going, instead of into the what to you perceives as the top of the key, it goes into the side of the key. So usually they have inherently higher tolerances because there's less material there for you to cut into. So to get 10 spaces, you got to get all the spaces much closer. You're not looking at 15 thou between each. You're looking at, like, I don't know, 7 or 8 thou between each. I think that's what multi-lock does. We don't have a guide for that at this time. We might look into that in the future. Dimple cutting equipment is not cheap, and it's not prevalent in the US. So that's not an easy thing to do, but it's definitely on my list of things that I might want to do in the future.
I see. Are there any restrictions about importing machines from other countries?
It can actually be easier to import machines than to convince someone domestically to sell something to you. But there's no real tangible restrictions on that. The only restrictions you'll end up with are contractual. So if you, for example, if you were trying to buy a multi-lock fancy code cut machine for their MT5 Plus or something, and they had some, contractual obligation that if the locksmith goes out of business, they have to return the machine, or they have to do something to it to make it useless. And then it went on eBay and you bought it. It's not really receiving stolen goods, but it is kind of, I don't know what would happen. So that there could be problems there, especially when you're with the higher end stuff, especially with newer stuff that's likely to still be in design patent. But as for blanket international regulations, no, you can't buy this. There's nothing, at least that I'm aware of. I'm not a lawyer.
Well, that does make sense. And let me see if we have any more questions. No, I think that's all the questions we have right now. We're about out of time. Also, is there some way that everybody can get a hold of you to reach you, contact you?
That would have made sense for us to develop, but no.
This talk was kind of thrown together on a whim. Yeah, we got nothing.
All right. Well, on behalf of all the Hope 2020 attendees, the presenters, and the volunteers, we want to thank you very much for sharing all of your great work with us today.
Thank you very much.
Pleasure to be here.
Thank you very much. All right, we'll come back at the top of the next hour, and we're going to have some new bumps in between, and take it away, ground control.